So we begin a new chapter. No, seriously, we're beginning a new chapter. Chapter 9. It's still on quadratics, so don't get too excited. But yes, be excited because we finally get to the quadratic formula.
Dang, it's math time with Mrs. Mauro. Once again, here we are. We are starting 9.1, chapter 9. And that is still quadratics, you guys, but we're going to start with some radicals. And you can see here what the objective is. Before we move on, I just want to remind you guys of a few little things that you need to know. Here are the parts of a radical in case you've forgotten. Remember the radical symbol, the radicand, and this is called the index over here. Do you guys remember how to turn a radical form into an exponent form? Well, if in case you don't remember, here we go. This radicand becomes your base. And now it's understood that this is an index of 2, and it's to the first power here. So this becomes 1 over 2. So this becomes x to the 1/2 is equivalent, but in a different form to this radical. So now if we tried this over here for the cubed root of 8, it would be our base. And what would be our exponent? Well, here it's understood it's a 2. This index is visible, it's a 3. That becomes our denominator. And we put a 1 right there. All right, so here we have 8 to the 1/3 power. And then the last problem here, again, notice this one has a 2 to the 3rd. Hey, guess what? That's the same thing as 8. But we're going to write it in exponent form, so we're going to turn it into a base 2. This 3 becomes our numerator, and our index becomes our denominator. So this is 2 to the 3/5 power in an exponent form. We're going to pretend we're playing a game here if Simon says. So Simon says we're going to simplify the square root of 360 using the steps below. Now, I'm using the calculator to help me to find the list just because it's easier. We can use a calculator and that's okay. So now step 2 says to find the greatest perfect square. That's a factor. I went ahead and I typed in different values for x, but notice what I typed in were perfect squares because that'll tell me what the other factor is. So I'm looking for the largest perfect square. So if we look here, it's going to be 36 and 10. Notice I'm ignoring all of the other values because they're decimals. We want 2 factors that are integers, they're whole numbers. There's no decimal or fraction to them. So I'm going to use 36 and 10. Step 3 says to rewrite the radical as a product of the perfect square. So here's my perfect square and its pair, which is 10. So I'm going to multiply them there. And then I'm going to separate the 2. So the square root of 36 times the square root of 10. And now I can go ahead and simplify the square root of 36, which I hope you guys remember is 6. And this radical 10 is just going to be at the end. And this is my simplified radical. I'm hoping you can make some connections here. Is the square root of 36 plus the square root of 64 equal to the square root of 36 plus 64? Well, let's find out. What's the square root of 36? 6. What's the square root of 64? That should be an 8, correct? 6 plus 8 gives us 14. All right, so now if we take 36 plus 64, we get 100. But if we take the square root of 100, that gives us a 10. So are these equal to each other? No, they're not equal. All right, let's take a look at the multiplication one of square roots here. So the square root of 4 is a 2 times the square root of a 9, that's a 3. 2 times 3 is a 6. And then when we multiply 4 and 9, we get the square root of 36 because it was underneath the radical. And the square root of 36 is 6. These are equal, so this one does work. They are equal. All right, let's look at the subtraction part now. We know this is an 8 minus the square root of 36, which is a 6. We get a 2 here. But then when we subtract that, 64 minus 36 is 28. So the radical, or the square root of 20, is not a 2 because that should have been a 4. So this is not equivalent. And here we have division. So the square root of 100 is 10. The square root of 4 is 2. 10 divided by 2 becomes a 5. Over here, we have the radical and the fraction underneath. 100 divided by 4 is 25. So that's the square root of 25, which is a 5. These are equal, so this one works as well. So this only happens to work when we have division and multiplication. On the guided practice, we're going to simplify the expressions. We're going to practice simplifying the radical. Think about what two numbers multiply to 24, especially with one of them being a perfect square. To my mind is that you've got the square root of 4 times the square root of 6. 4 times 6 is 24. Notice I put the radical on the outside. That has to be. And now I can take the square root of 4, which is a 2. And now this just gets moved over. So the answer is going to be 2 rad 6. For number 2, notice there is a negative on the outside of the radical, which means that we can still simplify, but our answer is going to be negative. So just like we did before, what is a factor of 48 that is a perfect square, and we want the greatest perfect square? So we can see that 4 goes into 48, but is there a larger number that goes into 48? And the answer to that is yes, it's 16 times radical 3. So I'm kind of doing a factor tree here, and don't forget the negative because it was right there. So the square root of 16 is a 4. Bring down the negative, and then you just bring down the radical. So the answer to this, when it's simplified, is negative 4 rad 3. All right, moving on to number 3, we're going to continue to practice this. What is the greatest perfect square that you can see going to 28? 4 times 7. 4 is a perfect square. The square root of 4 is 2 rad 7. And here's our answer. You try the next one. Earlier, I showed you how to convert radical form into exponent form. So we're going to go backwards, and we're going to just change it to the other form. So notice I took care of the number part. I left that out. So this will become g to the 6 over 2. Remember, the index becomes your denominator. Well, now let's simplify that. What's 6 divided by 2? And hopefully you can tell me that's a 3. So now here's the finale. Square root of 81 is 9. Notice this does not have a radical, so this will be included outside of the radical, and then you bring the radical 2 over. This is our simplest form. I know it looks kind of weird. Give it a chance. Number 6 has a negative on the outside, so I'm going to put that there. I'm going to think of what two numbers multiply to 512. Hopefully you can think of, or use your calculator. It's 256 times 2. Notice I put the radical there, okay? Don't ignore that leap. Make sure to put that there in your work. Now when you take the square root of 256 is 16. So I'm going to get a negative, a 16, and I'm going to have a radical 2. Now let's take a look at the h to the 7th power. So think back. If we have h to the 7th, how can that be turned into exponent form? There's an invisible what for the index, and I hope you guys know it's a 2, because if it's not there, it's understood it's a 2. So this becomes h to the 7 halves. Well, 7 divided by 2 gives you a remainder. This is going to look like h to the 3rd, and then you're going to have 1/2 left over. So this is not going to need a radical. So this is going to be on the outside. And this is going to remain as a radical form. So we're going to put the h inside with the 2, but this one gets to stay on the outside. So this is our final answer. Be patient with yourself. It's okay to struggle, but just try to look for those connections. Let's try it again. We have to be patient with ourselves. So as you look at 63, what two numbers multiply to 63? So rad I see a 9 and a 7. So 9 times 7 is 63. So if we take the square root of 9, that gives us a 3. We're going to have a radical 7. Notice our exponent is odd. So if I had the square root of x to the third power, that can be turned into x, 3 over 2. Notice this is going to simplify. 3 divided by 2 gives you 1 whole with a half left over. We don't need this one. So what that means is this one goes on the outside. This half remains with the 7. And this is our answer, 3x, completely free of any radical, but it's multiplying with the radical 7x. This is our answer. Let's try the next one. So what two numbers multiply to a 28? 4 and 7. And notice we have x to the 9th. If we take the square root of that, remember there is a visible 2, so this turns into x 9 over 2. So 2 goes into 9. We can say a total of 4 times, but we're going to have a remainder. This is on the outside, so I'm going to finish this over here. So this becomes 2, x to the 4th. This stays inside the radical, and 1x. And there we go. That's our answer.